Okay, let's go in the other direction. Now, one thing when we're going the other direction is we got to pay attention to which quadrant we're talking about. So we're going to take each of these rectangular coordinates and go to polar. Again, we're going from x and y coordinates to r and theta coordinates, using those same formulas that we had in the previous page. So the point here, 2, 2, that's in quadrant 1. Not going to be super important for this one, but we'll pay attention to that more later. So we're going to use the equation theta equals the inverse tangent of x over y. Sorry, y over x. I misspoke again. We got theta equals the inverse tangent of 2 over 2. Cleaning that up a little bit more, we got the theta equals the inverse tangent of 1. When we're doing inverse tangents, again, it's been a while since we've thought about this, we need to ask ourselves, where does the tangent of an angle equal to 1? We're looking for the angle measure that makes tangent of theta equal to 1. So if we go to the unit circle, I already have, and this is the one that I'll provide you with, I already have the values of the tangents listed there. So we're looking for a place where the tangent is equal to 1. There's a couple different options. We've got one option here and one option here. Now this is where the fact that we're in quadrant 1 is important, because we're in quadrant 1 of the rectangular coordinates, which means we're also in quadrant 1 of the polar coordinates. So the angle measure we're using there is going to be pi over 4. So we have theta equals pi over 4. The r equation, we got r equals the square root of x squared plus y squared. We got r equals the square root of 2 squared plus 2 squared, which is the square root of 4 plus 4, or the square root of 8. Square root of 8, not a nice square number. Let's break it down. We got square root of 4 times the square root of 2, which gives us r equals 2 times the square root of 2. So the theta, or the r coordinate for our final answer, is 2 root 2. The theta coordinate is pi over 4. For B, 3, 0, that's not really in any quadrant, so we're just going to say it's on the positive x-axis. Same deal. Theta equals the inverse tangent of y over x. So we got 0 over 3. So the inverse tangent of 0. So again, go to the unit circle. Go to the inverse tangent of 0. Where is tangent equal to 0? It's either here or here. But again, just like we said, we're looking on the positive x-axis. That's going to be over in this direction over here. So our angle measure is, well, 0 radians. So we got theta equals 0. For our radius, we got r equals the square root of x squared, so 3 squared plus 0 squared. So we got r equals the square root of 9 plus 0. Goodness gracious, that's just the square root of 9. We get r equals 3. So our coordinates are a radius of 3, angle measure of 0. Letter C, -4, -3. That's in quadrant 4. Plugging these in, we got the tangent, jumping ahead, theta equals the inverse tangent, let me zoom in, of our y value, -3, over our x value, -4. So we got theta equals the inverse tangent of 3 over 4. Now, we can go to the unit circle, look for where tangent is equal to 3 over 4. I don't see it listed. That's because it's not one of the nice coordinates. So what we're going to do is we're going to plug that into a calculator. Again, making sure when you do inverse tangent in your calculator that you do it in degree mode. You do it in radian mode. I'll show you a video of that later about how to make sure. So making sure it's in radian mode, we type it into a calculator. We end up with about 0.643. Now I want to go back to the unit circle. Again, 4,3, that's in this quadrant here, quadrant 3. Oh my goodness, I misspoke earlier. I don't feel like remaking this whole video. So, quadrant 3. My apologies. But we're in quadrant 3. That's down here. Now, we got an angle measure of 0.643 or 644, I believe it was. That's pretty small. 0.644, well, if this is an angle measure of pi, well, thinking about pi, that's 3.14159 whatever. 0.64 is much, much smaller than that. So what we're actually going to do is we're going to add, it's going to be in this here, but it's going to be added onto that pi. So we're going to do 0.64, man, I'm just doing a couple small typos on here, 644, and we're going to add that to pi, and we're going to approximate that using a calculator, which is going to give us theta equals 3.785. Again, that's rounded, it's not exact, but we know it needs to be more than pi, so we're going to add that 0.644 to pi. Our r value, we got r equals the square root of 3 squared plus 4, negative 3 squared plus, I should do it in the same order that I've been teaching you guys. I'm sorry, let me rewrite that one. So we got r equals the square root of our x squared, so negative 4 squared plus our y squared, negative 3 squared. We got r equals square root of negative 4 squared. Remember, it's in parentheses. Negative 4 times negative 4 is positive 16. Negative 3 squared, positive 9. So we got r equals the square root of 25. That gives us r equals 5. So our coordinates here, 5, 3.785. Let's do one last one here. We got theta equals the inverse tangent of our y value, square root of 3, over negative 1. So we got theta equals the inverse tangent of negative square root of 3. Again, the unit circle that I give you has the tangents on them, so we need to look for where tangent is equal to the negative square root of 3. Well, that's down here, but it's also up here. So wait, let's just double check. I kind of skipped over this. What quadrant are we talking about here? Negative 1 square root of 3. That's in quadrant 2. It's got a negative x value but a positive y value. So that means we're using the angle measure that's in the second quadrant. So that's going to be 2 pi over 3. So theta equals 2 pi over 3. Our r value, we got r equals the square root of our x value squared plus our y value squared. Negative 1 squared is positive 1. Square root of 3 squared is 3. So we got r equals square root of 1 plus 3, or r equals square root of 4. So we get r equals 2. So we got coordinate 2 pi over 3.